Okay, this is the notes and example problems over chapter 2.3, which is polynomial division. We're going to learn a couple different division techniques, what they're used for, and go from there. So the first division type is everybody's favorite, which is long division. We're actually going to take this polynomial here, 6x cubed minus 19x squared plus 16x minus 4, and I'm going to use what you would have done in 8th grade math, which is, you put a number outside the hut and then you divide it in and use long division. So I'm going to take x minus 2 on the outside. That's what's doing the dividing. And I'm going to divide it into 6x cubed minus 19x squared plus 16x minus 4. Now, whenever you do long division, you got to think about terms in columns. So I literally have an x cubed column here, an x squared column, an x column, and a constant column. So anytime I add something in there, I put that in the right column. So here's the trick. I want x, class, here we go. I want x to get to 6x cubed. It's missing a number in front, and it's missing how many x's? I'm missing a 6, and I'm missing 2 x's. For x to get to x cubed, I'm missing a 6 and 2 x's. So I need 6x squared is what I need to add on here. So I'm going to put 6x squared right there because those two will yield that. And then I distribute this to both of them. So 6x squared times 6x is 6x cubed, and 6x squared times negative 2 is negative 12x squared. Notice I put them in the right column. And what I always do is I use parentheses and I subtract. And that parentheses subtract, it allows me to remember to get my signs right. So 6x cubed minus 6x cubed cancels. Negative 19x squared minus a negative 12x squared. Those two negatives will make plus. So that's negative 19x squared plus 12x squared is 7x squared. And I got it to there. 12, no, oh yeah, negative. Let me see here. 12, 13, 14, 15, 16, 17, 18, 19. Yeah, negative 7x squared. I got it. And then bring down everything. Just like I know you only brought down in long division. You probably brought down that term. I want you to bring down everything just because of stuff that'll happen. So that's first. Second, now I need to get x turned into negative 7x squared. It's missing a negative 7 and an x. I'm going to vote negative 7x here, and then I distribute. Negative 7x squared, and then negative 7 times negative 2 is plus 14x. And then I remember to subtract. Negative 7x squared plus 7x squared cancels. 16x minus 14x is 2x, and I drop the 4. Now I need to turn x into 2x. What do I need? 2. I need the number 2 plus 2. So 2 times x is 2x. 2 times negative 2 is negative 4. And I will subtract. 2x minus 2x is gone. And negative 4 minus a negative 4 is also gone because that'll be plus. So that I get 0. And I know you probably put remainder 0 when you were in grade school. We don't do that. It's just remainder of 0. But what that does tell me is that if this goes into this and I get a 0 at the end, that means that went into that evenly, and that means this is a factor of this. So I'm going to write over here, x minus 2 is a factor of the polynomial. And that is really pretty important for what we're going to do down the road. We have to know that. Now, that was long division. We use that sum, and here's a method you've probably never seen before. It's called synthetic division. Okay, synthetic division. Here's what you do. You take the 0 of the factor. So if x minus 2 is the factor, class, what's the 0? 2. And you put it here. You invert the division bar, and you leave a little space down here. Now what you do is you take all the coefficients and you line them up. The coefficients are 6, negative 19, 16, and negative 4. 6, negative 19, 16, and negative 4. Again, this is a process called synthetic division. Line it up like that. I'm going to do it once, and then I'm going to erase it, and I'm going to do it a second time. The first time I do it, I just want you to watch. I don't even want you to write anything down. I want your brain to process what's going on. Process called synthetic division. Okay, here's your rule. Drop it. 6. Multiply it. What do you get? 12. 12. Add it. What do you get? Negative 7. Multiply it. Negative 14. Add it. 2. Multiply it. Add it. Remainder constant x squared. 6x squared minus 7x plus 2.
What? That was so what?
All right.
It's like Miss Taylor telling us to, like,
We're going to try it again.
time, and it shows this, like, after this test.
Here we go. Are you ready? It's called synthetic division. Okay, let's try it. We're going to do this a lot. We actually use this a lot, so you will have this down. You cannot do this chapter without doing this. You will have this down. So here we go. Drop the 6.
Drop the 6.
Okay, so you have a new thing.
Multiply and write it there.
Well,
Add. Negative 7. Multiply. Negative 14. Add. 2. Multiply. 4. Add. And by the way, there might be more numbers this way. If that's so, you go remainder, constant, x squared, x cubed, x to the 4th. Right now we have a remainder of 0, remainder, a constant of 2, an x value of negative 7, and an x squared value of 6. So the result of dividing this by this is the polynomial 6x squared minus 7x plus 2 is the result of dividing, and we notice they are the same.
Let's do it again.
We'll do it a lot.
one more time.
Wait.
We're going to do that a
No,
lot.
let's do it with another show.
Now, so here's the question.
What if there's a number?
Why not just do this every time and not, this was terrible.
Yeah, look at it. It looks just so much messier.
That was, oh, way better, yeah.
If there's like, what do we do if there's a number in front of the x?
There you go.
Okay.
There's the kicker.
Oh.
This synthetic division only works when there's a leading coefficient of 1 and there's an exponent of 1. If there's an x squared or a number in front, you can't use synthetic division. It only works in this specific case. However, this specific case appears enough where we use this most of the time.
Wait, awesome sauce.
Why do we use positive two instead of negative?
You use the 0. X minus 2 equals 0.
Oh.
If x minus 2 equals 0, that means x is 2, and the 0 is what goes out in front. The 0 is what goes out in front. Again, it's called synthetic division. And I put some of those notes down here at the bottom. Look, your division algorithm, I'll show you this. There's a rule that says when you write your answer, you write the divisor times the quotient plus remainder. I'll show you that here in a second. But another one, synthetic division only works. The degree has to be 1. It can't be x squared that you're dividing by. If it is, you can't do it. Your leading coefficient has to be 1. You can't use synthetic division for 2x plus 1. There is a fancy trick where you can turn everything into a fraction and do it, but most people, I might show you that. We'll see. And the divisor has to be a binomial. So this has to be a binomial, x minus 2. You can't just randomly do it for anything. So there is some limitation to synthetic division, but it does work great. So here's my page. We're going to do some division here, and we'll write our answer. The questions say this: divide each however you want. Is a given divisor a factor of the dividend? Write the quotient as factors with remainder if needed. So I have A, B, and C. Kind of a mouthful of things to do there.
Yes.
All right, so here's the first one. Is synthetic division an option?
Yes.
Yes. What would go outside the hut? 2. Inside the hut? 1, 3, 5. Drop it, multiply, add. Multiply, add. See if you guys can do the synthetic division right now. Drop the 1, multiply, and go with it.
Drop, multiply, add.
Drop here, bring the 1 down. You multiply it here, and then you put it there.
And then add.
And then you add them up. Yep.
Want to do the other one too?
Yeah, I'll do that one over there here in a second. There's a trick on that one. So I'm gonna drop the 1. 2 times 1 is 2. Add, I got 5. That's 10, yes? And then I add it and I got 15. Okay, so part A was divide however you want. This was part A. Part B, I think, said, is this a factor of this? Yes or no?
No.
No, because
There's a remainder.
there's a remainder. Not a factor. There is a remainder. If we have a remainder, that means this won't go into this evenly. And you guys know that from whatever. I'm going to make sure I'm doing everything right. Divide however you want is a given factor. Divisor. Write the quotient as factors with remainder if needed. Okay, so here's my answer. My answer is remainder constant x. So the result of the division is this. X plus 5, yes? X plus 5 plus, how do we write that idea? Yes?
15
15
over 2.
over, try again,
Negative 2.
the whole thing,
X negative.
x minus 2. Whenever you write the end of it, if you have a remainder, you put the remainder over what did the dividing. So x minus 2 did the dividing. It was the binomial that divided into that. 15 was my remainder, so I put 15 over x minus 2. That's it. That's the whole thing. If I wanted to write it as factors, I would say this polynomial is really x minus 2 times x plus 5 plus 15 over x minus 2. Guys, if you were to do the foiling, if you were to FOIL this times this and distribute it and get rid of fractions and all that, if you're able to write that, you would get back to the original polynomial. Kind of crazy. Okay. X cubed minus 1 divided by x minus 1. What goes outside? 1, the 0. Now, watch this and see if you can comprehend why I did what I did. Are you ready? Watch. Watch. Watch me. Watch me. Here we go. 1, 0, 0, 1. Oh, what'd I do? Missing x squared and I use placeholders. 1x cubed, 0x squared, 0 x's, and 1 constant. You have to have placeholders. You can't just drop things out. You guys try the synthetic division on that one. I missed a sign, didn't I? -1. Look, I put 1, 0, 0, and that -1, that should go with that. That one is the 0, so that should be positive, but that spot should be negative. I think that changes your answer quite a bit. Like, it makes it a factor when it wouldn't have been a factor had I dropped the wrong sign. Sorry about that. So your answer would have been 1 down, 1 times 1, 1, add 1, multiply, 1 times 1 is 1, add 1, multiply 1, add 0.
Where'd you get the 1, 0, 0, and negative 1?
So 1x cubed,
Okay.
0x squareds, 0 x's, and -1 is the constant.
Why
So
would you put
that
3 zeros?
is there. Where would the third 0 come from?
I'm being attention. Everything follows my
1x cubed, 1x cubed, 0x squareds, 0 x's, and the constant. Got it?
Look at my
Okay. Remainder, constant, x squared. My answer is part B. Part A, I use synthetic division. Part B, is this a factor of this? Yes. Is a factor. And part C, the result of the division is x squared plus x plus 1 would be the result of the division.
Awesome.
Yes?
What are the zeros a placeholder for?
Okay, so here I'm dividing, this is what goes inside, right? 1x cubed. How many x squareds are there? 0. How many x's are there? 0. And then the constant is the 1. If there's missing terms, you have to put placeholders in there for the zeros.
If it's a remainder of 0.
Yeah, it's a remainder of 0, you get a factor. Okay, here we go. Can I use synthetic division?
No.
So I have to use long division.
Woo.
The big one. Here we go. X squared plus 2x minus 3 into 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2. I'm gonna guide you, but I'm not gonna tell you right away. And try this. Don't just wait for me to do it. See if you can put the right term there. Here's what I'm gonna tell you first. You're gonna end up, your first multiplier is gonna go in this spot right here.
Yeah.
You're gonna put a number right there. See if you can get that number right now.
Oh, I got it. Ooh.
I gotta turn x squared into 2x4. What has to go there?
2x squared.
2x squared. So 2x squared goes there. Now here's what you're gonna do next. You're gonna FOIL that, distribute that through, and write it out underneath there, and then try to subtract them. See if you can do that step.
X squared. And then I drop 2, right? I drop both 3x minus 2.
Yeah, I'm gonna drop them both.
Okay.
So I got 4x squared. Oh wait, 2x squared. Sorry, 2x4. Let's try that again.
Wait.
2x squared times x squared is 2x4. 2x squared times 2x is 4x cubed. Yes? Oh, look at that. Haha, that's cool. All right, and then those two, 2x squared times negative 3 is negative 6x squared. Is that what you got?
Yep.
Don't forget to subtract. 2x4 minus 2x4 is gone. 4x cubed minus 4x cubed is gone. And what's negative 5x squared minus a negative 6x squared? X squared. So I drop. Drop the 3x, drop the 2. So I drop the 3x, drop the 2.
See what I did?
Okay.
Right.
Now
what
what
I
do
did?
you do? This is where
Now,
You times
I
four.
have to get a number times that to get to that.
and it already is that.
It's 1. I'm going to put a plus 1 here on the end.
Okay.
Plus 1 there on the end. So now I'm going to do the multiply. And I'm going to take that number, I'm going to multiply through. And I got x squared. 1 times x squared is x squared. 1 times 2x is 2x. And 1 times 3 is negative 3. Minus, gotta subtract the 2. X squared minus x squared, gone. 3x minus 2x. X, negative 2 minus a negative 3. Plus 1. How do I know I can't go any farther? A couple reasons. One, I got to the end of my column. And 2, that exponent is bigger than that exponent. I can't do anything. That was part A. We had to use that division. Part B, is this a factor of this?
No.
Not a factor. And the last thing, part C, that I'm going to do is I'm going to write my answer. I'm going to write it as x squared, or 2x squared, this 2x squared plus 1 plus the remainder
X plus 1 over x squared.
over the divisor, over what divided, which is x squared plus 2x minus 3. All right, we're gonna put one more on this video, and then I'm gonna skip to the next video. So I'm gonna divide 4x cubed minus 7x squared minus 11x plus 5. I'm gonna divide it by 4x plus 5. There's a number in here that says don't synthetically divide.
4x
The 4.
cubed.
So I got long division again. 4x plus 5 into 4x cubed minus 7x squared minus 11x plus 5. See if you can pick that first multiplier out and put it where it goes.
Let's equal 0.
I think this one works out evenly if I remember right. I'm not 100% sure. So I have 4x here, and I have 4x cubed here. What does it need? It needs x squared. It goes in the x squared column. So I put an x squared here. Multiply, see what you get. Plus 5x.
What's
Squared.
15?
I don't know, maybe this one does have a remainder, I don't really remember. So I got
11 plus
4x
2
cubed
is
minus 4x cubed is gone. I got negative 7x squared minus a 5x squared. Did you guys get negative 12x squared there?
Yeah,
Okay. Minus 11x plus 5.
and then I took, there's a remainder,
I don't know, I'll have to see.
how's the remainder?
All right, so what's your multiplier now?
3x.
Negative 3x, because I gotta get to negative 12.
Do you get to negative 12?
Yeah, because I want them to cancel out. When I subtract, I want them to cancel. So you always have the same sign up here, so you want the signs to be the same. So negative 3x times times 4x, those two is negative 12x squared. Negative 3x times 5, minus 15x, and I subtract. Yeah, the signs are what usually get people. Like, people understand the process, and then the sign gets them off. So negative 12x squared minus a negative 12x squared is gone. Negative 11x minus negative 15x is 4x. And I think it's easy to see the last number is a 1. And then I get 4x plus 5 underneath it. I subtract it and I get a 0. Is 4x plus 5 a factor of that?
Yes.
Yes, it is. So part B, it is a factor. It is a factor. And the result of division is x squared minus 3x plus 1.
I've got a question number 18.
Part C. All right, I'm going to stop it there. There will be a part 2 of this coming up here shortly.